side-by-side bar graphs. The following data represent the educational attainment in 1990 and in the year 2013 of, actually this should be 2017. I updated this, of adults 25 years and older who are residents of the United States. The data are in thousands. Draw a side-by-side relative frequency bar graph of the data and make some general conclusions based on the graph. So what we have here is information about educational attainment. We have two different years. We have 1990 and we have 2017. So in 1990, there were 39,344,000 individuals in the United States who did not have a high school diploma. Now, again, I want to point out these data are in thousands. So when this says 39,344, that's thousands, meaning that there's really 3 more zeros behind it. So that's really 39,344,000 individuals. In 2017, there were only 26,582,000 individuals who did not have a high school diploma. And again, we're talking about people who are 25 and older, and so on. So we're supposed to draw a side-by-side relative frequency bar graph of the data. So I've basically already done that here on the second page rather than taking time to draw it by hand. So what I did is I found all of the relative frequencies. So if we take the 39,344,000 and divide by the 158,870,000, that gives us 0.2476. So about 25% of the population in 1990 did not have a high school diploma. If I take the 47,643 and divide by the 158,870, that gives me 0.2999, so almost 30% of the individuals had a high school diploma as their highest level of education, and so on. This divided by this gives me the 0.1874, so almost 19%. This divided by this gives me 0.0616. This divided by this gives me 0.1311. And this divided by this gives me 0.0722 for 1990. In 2017, this divided by this gives me 0.12, so about 12% of the population in 2017 did not have a high school diploma. This divided by this gives me 0.27, so about 27% have a high school diploma as the highest level of education. This divided by this, 0.2039, so about 20% have some college but no degree. This divided by this gives me 0.0848, so about 8.5% have associate's degrees. This divided by this gives me 0.197, so almost 20% have a bachelor's degree. And lastly, this divided by this gives me 0.1229, which is about 12% of the population have a graduate or professional degree. So in a side-by-side bar graph, what we're going to do is we're going to do bars for 1990 and for 2017. So in my case, I'm using a blue bar for 1990 and green bars for 2017. So the height of the blue bar here for not a high school graduate is right up to the 0.25 mark, whereas in 2017, it's only up to the 0.12 mark. And then so on for the high school diplomas, for the some college and associates, a bachelor's and a graduate degree. So we draw it the same way, we just really have sort of two things that we're comparing side by side. And so that's what a side-by-side bar graph is. One other question about that before I move on. Why in this case would it be better to do a relative frequency bar graph than to do a frequency bar graph? Why would I use relative frequency here in my example instead of frequencies? Well, it actually does matter in this case that we're going to use a relative frequency instead of a frequency distribution because I'm comparing 1990 to 2017. Now, here's the reason why it matters. Notice that in 2017, we have a bigger total. We have 221,251,000 adults that are 25 and older in 2017. In 1990, there were only 158,870,000 adults 25 and older in the United States. So the fact that we have different totals here matters. These values here, these frequencies are going to be bigger than these frequencies here just because we have a bigger population. So it's not really fair to compare these two numbers to each other because the totals are different at the bottom. So a fairer comparison is to look at the relative frequencies, the percentages, if you will, instead of looking at the raw numbers. So that's why we looked at the relative frequency. So here, 24% of Americans 25 and older didn't have a high school diploma, whereas here it's dropped to 12%. Here it was nearly 30%. Here it's 27%. 18%, almost 19% versus 20%. 6% versus 8%. 13% versus almost 20%. 7% versus 12%. So again, comparing the relative frequencies is a fairer comparison for comparing 1990 to 2017 than comparing the frequencies. Okay, so I think that's probably enough said. So just be aware of that. Most of the time when you're going to do a side-by-side bar graph, you will want to make it relative frequencies instead of frequencies. There can be exceptions to that, but typically we would want to do relative frequency. Horizontal bar graphs. Now, most of the time when bar graphs are drawn, normally they're drawn vertically. The bars are drawn vertically, but they don't have to be. It's perfectly fine to draw a horizontal bar graph. So we have the same graph that I'm showing you up here. This is the exact same graph here, except we've just drawn the bars horizontally instead of vertically, but the information's still the same. Like for example, if you had to make a comment about educational attainment of 1990 versus 2017, do you see that the bars are getting shorter over here on the left and taller over here on the right in comparison to what they were in 1990? So in other words, in 2017, there's fewer high school dropouts. There's more people with bachelor's degrees and people with professional and graduate degrees. So it would appear that the amount of education, the amount of schooling is increasing from 1990 to 2017. In the same way, you can see that same thing if we have the horizontal bars. Notice again, the not in high school, it's still, the green bars are shorter up here. So there's fewer people not finishing high school, and there's more people getting bachelor's and graduate degrees than there were in 1990. So again, it's perfectly fine to draw bar graphs horizontally if you want to. It's more of an artistic preference than anything else. Pie charts. A pie chart is a circle divided into sectors. Each sector represents a category of data. The area of each sector is proportional to the frequency of the category. So use the 2017 educational attainment data from the previous example to construct a pie chart. So this is the 2017 data. These were our numbers and these were our relative frequencies. Well, if I want to create a circle graph, the reality is nobody does that by hand anymore. Technology has replaced any need for anybody to draw a circle graph by hand, so it's rarely ever done. But I do want you to understand the math that's behind it. So if not a high school graduate represents 12% of the population in the year 2017, then 12% of the circle should be representing not a high school graduate category. Now, a full circle, a full revolution is 360 degrees. So if I take 0.1201 times 360, that is about 43 degrees. So this angle right here is about a 43-degree angle. And then if I take 0.2713 times 360, that is almost 98 degrees. So for a high school diploma, high school diplomas here, that is about a 98-degree angle that's drawn right there. So if we had to do this by hand, we would like start with this line, measure a 43-degree angle, and that would represent not a high school graduate. Then from there, a 98-degree angle, that would represent high school diploma, and so on. If I take 0.2039 times 360, that's going to be about 73 degrees. So this angle is about 73 degrees. And 31 degrees would be this angle. And 71 degrees would be this angle. And 44 degrees would be this angle. So that's how a circle graph is constructed if you had to do it by hand. Again, nobody does that by hand anymore. So instead, we're going to use technology. So I'm going to pull back up StatCrunch and show you that again. So if I want to create a circle graph for this blood type data, I call it a circle graph or a pie chart. So if I go to graph, now when I point at pie chart, I get these two options. Do I have data or do I have summary information? In this case, I have data, as opposed to it's not already summarized in a frequency or relative frequency distribution. So I'm going to say data. Now I get this window, which is pretty much the same kind of window we had for the bar chart. So I'm going to select the name of the column, which in this case is variable. I think this is actually the data that came from the homework problem in my math lab than from the textbook, but it's not a big deal. The important thing is how do I use it, okay? So I'm selecting that var1, okay? And then by default, it says to display the counts and the percent of total. So I'm going to leave that there, and I'm going to just say compute. So when I compute, it creates this graph for me. So I can see here that A, if I point at it, the frequency was 17, and that was 34% of the blood types. So the relative frequency was 0.34. If I point at AB, the frequency was 3, and that was 6% of the 50 data values. So 0.06 is the relative frequency, and so on. And incidentally, they also give me this over here. I can tell that from over here as well. So I do want to mention one more thing about StatCrunch here, and that is the homework in my math lab. When you have to create a circle graph or a bar chart, my math lab doesn't really have a tool for you to be able to do that. So you're not going to be able to do that in my math lab to be able to create your bar graph or your circle chart. So those kinds of problems are always going to be multiple choice. They're going to give you multiple choice options for which bar graph or which circle graph is the correct one. Now, I want to warn you, in those problems, look very, very carefully, because all of the graphs that they give you are going to look very close to be correct. So it's usually like some technicality. That's why one graph's correct and another's not correct. So pay very close attention to that. You might have one bar that's a little bit too high or a little bit too short compared to some of the other graphs if you're talking about a bar graph. And the same way on a circle graph, it might have one piece of pie slightly in the wrong size, but it's not going to be obvious always. You got to look very carefully. Another thing why I started mentioning that is typically, like what you can see right here is our graph is starting here and it has A, B, and O. the pieces of pie in the multiple choice answers may not be in the same order. So I want to show you that you can kind of manipulate that a little bit. As I was creating this, I want you to notice this option right here. This option says value ascending. So what that means is, if you look at this graph right here, ascending order as far as StatCrunch is concerned means alphabetical. So it's starting with A, then it went to AB, then it went to B, then it went to O. So it put these pieces of pie in alphabetical order. If I choose something different there, if I choose values descending and recompute, now it put them in reverse alphabetical order. So it did O first, then B, then AB, then A. So I can change that. If I choose to go in the order in the worksheet, now what that means is this. In the list of data, O came first, then B, then AB, then A. So it went O first, then B, then AB, then A. So it went in the order that the data showed up in the worksheet. So you might be able to make your circle graph look more like the ones in the multiple choice options. Another thing that's pretty common, the multiple choice answers oftentimes start the first piece of pie up here with a line straight up and down like was in our book, instead of these by default are starting over here. So the way I can change that is by changing the start angle that you can see right here. So if I change that start angle to 90 instead of 0 and recompute, it's the same graph, but it's starting with this line up here, and then it's finding O and B and AB and so on. So you probably may want to manipulate that a little bit in order to get them in the same order that your multiple choice answers are in.